All right, the last key idea for quantitative reasoning is interpreting specific points, including points of intersection. So, how do we make sense of particular points in a table or graph? Consider a point as a snapshot of that situation. If you don't know what a point is, you may call it an ordered pair, an XY pair, coordinates. Those are all different ways of talking about a point within a graph or a table. And it's just talking about a snapshot, like one particular moment in this story that's being told. So you want to, just like we've been doing this whole time, use the labels on the table or graph to figure out what quantities are involved, and that's going to tell you what that particular point, what that particular snapshot means. A point of intersection is a particular type of point when two or more quantities have exactly the same value. So their x's are exactly the same, their y's are exactly the same. That's a point of intersection. They're often particularly important moments in a table or graph. Often when we're solving a problem, we're trying to find some point at which two things are exactly the same, so that way we can compare them. So that's when we want to look for a point of intersection. Oftentimes, a point of intersection will indicate that two quantities are crossing, but that's not necessarily the case. So we need to consider that and make sure that we're reading carefully those labels on our tables and graphs so we know whether we're guaranteed that it means that they're crossing, or maybe it doesn't. It just means that they're reaching the same value at some particular time in the story. So here's a table and graph, and for this one, we've actually got the table and graph relating to tell two different sides of one story. So we've got this table where we've got a certain amount of hours that are passing, and then we've got the money in Tina's account and the money in Tara's account. So again, really important to always read your labels there. Other than that, we've got, so if we investigate the table a bit, we can see that our hours are increasing. And then we can see that in Tina's account, it increases, then stays constant, then decreases and stays constant. In Tara's account, it decreases right away and then stays constant the rest of the time. Then we've got this graph, and it says that the graph above shows the distance of two sisters, Tara and Tina, from their home on a certain day. Tara's distance is shown with the red graph. Okay, so that's important to note. Tara is the red graph, so maybe I should actually, to kind of help us keep track, since Tara's is the red graph, I'll go ahead and use red to mark Tara's money. And then it says that Tina's distance is the blue graph. So I'll use blue for Tina. And the amount of hours applies to them both. So this is all related. And we can see that on our graph, the x-axis is the time in hours as well. So we can do some comparisons since we're talking about, and even the same time frame, right? From 0 hours to 10 hours. This starts at 0, 2, 4, 6, 8, 10. So from 0 hours to 10 hours. So it's over the same time frame. So that lets us know we can make some comparisons between this situation. Our y-axis, let's see, we talked about our x-axis being time in hours. Our y-axis, our vertical axis here, is the distance from home in miles. And we've got something a little bit different this time because the axes are actually scaled. So we actually have numbers we can work with. Here, each label, or rather each grid line is labeled. So we can see 1, 2, 3, 4, 5, 6 all the way across. On our x-axis, though, it's only every other line. No big deal. You can still figure out what goes in the middle. So between 0 and 2 should be 1. Between 2 and 4, right in the middle, would be 3, and so on. So if it makes you feel more comfortable, you're always welcome to fill in those labels for your graph if you want, but you don't have to. All right, so let's try and make sense of what's happening in our story. And it can help to just kind of look at one thing at a time. So let's go ahead and start with Tara. And remember, Tara is the red graph. So if we look at Tara's journey, again, this is distance from home for Tara and Tina. And they're leaving from their home, so they share the same home. So it starts at 0. the blue dot is over it, but we can see that our red line is going right to the same place. So she starts out at home. Her distance from home is 0. Then it increases, stays constant for a bit, and then decreases. Versus if we look at Tina on the blue graph, we can see that she's also starting at home. She stays at home for a while. It stays constant at 0 distance from home, but then she increases, stays constant for a little bit, and then decreases. All right, if we look at the values in the table, we can see that Tara, who's our red graph, so from 0 to 2.5, her amount of money decreased. So she had $30 at the beginning. By the time she gets to 2.5, which would be halfway between 2 and 3, so that's about here. By the time she gets there, she's decreased to $10 in her bank account. And then we can see that Tara stays at $10 the whole rest of the story. So the rest of the time that she's staying 3 miles away from home, she's at $10 in her account. And then as she slowly makes her way back home during this decreasing portion of Tara's graph, she's still got $10 in her account. If, on the other hand, we want to look at Tina, so she starts out with $0 at the beginning. She's got nothing in her account. By the time she gets to 2.5, which is right here, she has $30 in her account. And then she stays at $30 when she's at 5. At 7.5 right here, that's when she drops down to $10. And then she stays at $10 all the way until that 10th hour. Okay, so if we wanted to imagine kind of what's happening here based on our graph and based on our information, with Tina, it seems like she stayed home for a little bit. Maybe she asked a friend for money, and so that's because she didn't have any money, so she couldn't go anywhere, and she borrowed some money from a friend maybe, or maybe she was able to deposit some money into her account, and so that's why she ended up with $30 by the time we get to this point. And we can see that she then is traveling away from home. Then her money drops. It decreases between 5 hours and 7.5 hours. So at some point here, she loses $20. So maybe, let's see. So she's staying the same distance from home from 7 hours to 9 hours. So she stays for 2 hours. So maybe she's grabbing dinner. Maybe she's hanging out with a friend and loans them some money. So something happens at this point where she loses some money, and then that's it. She then goes home. And in fact, it's worth noting this is pretty steep here. So she's rushing home. She makes it 5 miles in 1 hour, which isn't very fast. 5 miles per hour is not all that fast, actually. But it is if you're like walking. So if she was walking, that would be quite a pace to keep up for 5 miles. Maybe she's a cross-country person. All right, let's talk about Tara. So Tara starts off right away. She has $30 in her account, so she just goes right along. And then by the time she gets to 2.5, she spent $20 and she's down to $10. It's decreased. So again, thinking about what does that maybe mean? Let's see, she stopped a certain distance from home. She's staying the same distance away for 1, 2, 3 hours. So again, maybe grabbing a meal, maybe visiting a friend, maybe watching a movie. So something that cost her $20, and she stays there for a little bit, and then she's able to slowly make her way back home, just taking her time. So that's how we might interpret the table and the graph together to try and make sense of what's maybe happening in this story. But one of the things I mentioned in the last slide was that idea of a point of intersection. So a point where these graphs have the same value is right here. At 5 hours, they are both 3 miles away from home. So it's possible that at this point they cross paths. Maybe, like I said, Tara might have been at the movie theater. Maybe as Tina was making her way over to her friend's house, she passed the movie theater. And so maybe she and Tara saw each other here. But that's not necessarily what happened, because all that we know is that their distance from home was 3 miles. That could have been 3 miles in the opposite direction. So it's possible that Tara went 3 miles north and was 3 miles north from home after 5 hours. And then Tina could have gone 3 miles south and been 3 miles south after those 5 hours, in which case they are 6 miles apart, and not in the same location at all. So again, all that a point of intersection tells us is that we had the same value for our quantities. At 5 hours, both Tina and Tara were 3 miles apart. Or rather, we're 3 miles from home. Sorry, you should be specific there. A few other points of intersection, places where they're the same, are here at 0 hours. They were both 0 miles from home. They were both at home. And again, at 10 hours, they were both back at home. This might indicate a day that they spent out, maybe on a weekend, and then maybe after 10 hours, it was their curfew, so they had to be back home. Maybe that's why Tina was running so fast. You can find intersections also in a table. So if we look at our table here and we're comparing maybe Tina and Tara, we can see that Tara's got more money than Tina's got more money. And then at the end here, we've got some intersections. So at 7.5 hours, both sisters have the same amount of money, $10. And again, at 10 hours, we can see that they have the same amount of money. They have that $10. So hopefully that makes sense as far as how we can reason about points on a graph and intersection points especially. So some key check for understanding questions here. Think about, what do the coordinates of points on the graph or points in the table tell you about the situation? And also make sure you understand what it actually means when those two graphs intersect. Does it always mean that two things are crossing paths? We know not necessarily. So how do you tell what an intersection on a particular graph means? Where are you going to look, and what are you going to look for? With that said, that's quantitative reasoning. That's the entire first lesson of topic 1 in Edgenuity. So hopefully that helped you guys.